For models, when you're running in either numerical RTA or the numerical model, when you're running the models on bottom of pressure, which you inherently do in numerical RTA, a lot of noise can be introduced by these outlier data right here. That is calculated and typically come from calculated data where either you have a wrong, water rate or a airiness surface pressure reading. And that kind of spikiness in the data and controlling the model like that can introduce a lot of noise in both the predicted rates and sometimes can even lead to convergence issues. So that's why we've included this way of graphically excluding these points that you don't want to include in your data, and then there'll be an interpolation exercise in between. So if I take this data right here, all the data that I think is not real measurements, of course that's subject to interpretation. So let's say it's all of this data, right? Maybe that data as well, and then I include all that. And then all this data is now highlighted in a lighter gray, if you like. It's more transparent. And then I'll do the same for all of the data below what I think is correct. And what the software will go ahead and do for all of this data is to interpolate between these data points. So use an average of whatever is before and after. And then when I've done that work, I can simply just run the model, and at least in terms of spikiness of the results itself, that should be now reduced because of this quote unquote new bottom of pressure, cleaned out bottom of pressure history that I'm running the model on. So when these numerical RTA results are finished and they're plotted on the screen, you should see that these bottom of pressure runs right here that is behind the numerical results, they are actually much cleaner than what the case would be if I did not do that smoothing.